Of all the planets in our night sky, none quite captures our imagination like Mars, does it?
Definitely not.
For millennia, it's been this source of wonder, myth, and, well, increasingly dreams of exploration. But if you've ever tried to spot it with a backyard telescope, you know it can often be, frankly, a frustratingly tiny, blurry dot.
Oh, absolutely.
Yeah.
It can be quite disappointing sometimes if the conditions aren't right.
So, what if I told you there's a cosmic sweet spot? A truly special time when Mars comes closer, shines brighter, and really reveals its secrets even to modest instruments.
You're talking about opposition.
Exactly. An event so spectacular for Mars observers, it's often called the Astronomical Super Bowl. We're diving deep into Mars opposition.
That's right. And in this deep dive, we're going to unpack exactly what an opposition is, when to look for it, and what fascinating details you can truly expect to see.
Okay.
We've sifted through a stack of pretty insightful sources to equip you, our listener, to witness the red planet at its absolute best. Think of this as your essential guide to a truly incredible celestial show.
Okay, let's unpack this then. So, what exactly is this opposition everyone gets so excited about? Is it just like when Mars and Earth are generally close?
It's a bit more precise than just being generally close. Actually, the easiest way to visualize it is to imagine our solar system as a kind of giant racetrack.
I love that analogy. So Earth and Mars are like two cars racing around the sun, but Earth's in the inner, faster lane.
Precisely. Earth, being closer to the sun, has a much shorter lap time than Mars. It takes us about a year. Mars takes almost 2.
Right.
So because of this, Earth eventually overtakes Mars roughly every 26 months or so.
Okay.
And opposition is that exact moment when our planet, Earth, passes directly between the sun and Mars. You get this perfect straight line. Sun, Earth, Mars.
Sun, Earth, Mars. Got it. So if we're directly in the middle, does that alignment present any, challenges for observation, or is it purely beneficial?
For observers on Earth, it's almost entirely beneficial.
Yeah.
The results of this cosmic alignment are pretty significant.
Oh, like what?
Well, first, it guarantees Mars is at its closest approach to Earth during that period. Not always exactly on the opposition date itself, but very near it.
So it looks bigger.
Significantly larger in a telescope, yeah. Second, it means maximum brightness. From our vantage point, Mars is fully illuminated by the sun, kind of like a full moon.
Oh, okay.
Reflecting the maximum amount of sunlight back to us. During an opposition, it can shine at a stunning magnitude of -1.4.
Wow, -1.4. That's incredibly bright. For someone completely new to astronomy, is it easy to confuse Mars at opposition with another bright star, or does its, distinct color always give it away?
Its color is usually the big giveaway. It's that distinct orange-red, sometimes more ochre. And unlike a star, which twinkles because of our atmosphere,
Right.
Mars will usually have a steady, almost unwavering glow, much more planet-like.
Good tip.
And this alignment also means all-night visibility. This is huge for observers. Mars rises in the east around sunset, arcs across the sky all night long, and then sets in the west around sunrise. So you have these extended viewing opportunities.
Plenty of time to find it.
Exactly. And that full illumination. It also greatly enhances the visibility of its surface features, which is, well, what we're really after when we observe.
And its apparent size. We know it looks larger, but, how much larger are we talking? Give us some context.
Yeah, so at a typical opposition, Mars might measure about 14.6 arc seconds in diameter.
Arc seconds. Okay, tiny units.
Very tiny units, yeah. But now, put that in perspective. When Mars is farthest away, on the other side of the sun from us, it can shrink to a mere 3.5 arc seconds.
Wow, that's a huge difference.
It really is. So opposition makes it appear more than 4 times larger in diameter. Now, what's truly fascinating and rarer are the perihelic oppositions.
Perihelic, meaning?
Meaning Mars happens to be near its closest point to the sun at the same time as it's at opposition with Earth.
A double whammy of closeness.
Exactly. And during those, it can appear as large as, say, 24 arc seconds.
Yeah.
That's a truly spectacular view through a telescope.
That's a noticeable difference indeed. Speaking of timing, because these events are so special, when are the next great opportunities to see Mars at its best? We know oppositions happen roughly every 26 to 27 months.
That's correct. And just for context, we recently had one back in January 2025. That specific event occurred on January 16th.
Okay.
With its closest approach actually just before that on January 12th. At that point, it was about 59.7 million miles from Earth.
And I remember hearing about that when during that 2025 event, Mars was shining brightly up in the constellation Gemini, right?
Right, named Gemini.
And wasn't there something cool involving the moon around then, too?
You've got it. For those who were watching closely, yeah, a unique viewing opportunity happened on January 13th, 2025. We had a full moon briefly obscure Mars.
Oh, wow.
In what's known as a lunar occultation. Basically, the moon passed directly in front of Mars from our perspective, temporarily hiding it. Yeah, it was pretty neat. The peak viewing for that 2025 opposition was generally around midnight local time.
Now, this next point is crucial for planning ahead. While we're past the 2025 event, the next really prime opportunity is just around the corner. You actually have plenty of time to get ready for what promises to be an excellent showing.
Absolutely. And looking ahead, our sources provide some fantastic upcoming dates to mark on your calendar. One indicates the next major opposition is on January 19th, 2027.
January 19th, 2027.
Okay, with the absolute closest approach actually happening about a week earlier, on January 12th, 2027. And during this time, Mars will be shining brilliantly in the constellation Leo.
Leo the Lion. Got it.
However, it's worth noting, another source we looked at states that following the January 2025 opposition, the subsequent opposition is expected on February 19th, 2027.
Huh. So January 19th or February 19th, 2027, a little bit of a difference in the exact official opposition date, perhaps.
Yeah, slight discrepancy, which can happen depending on calculation methods or definitions. But
the clear takeaway is that the entire early part of 2027 offers a fantastic window.
Exactly. That whole period around January, February 2027 is prime time. You've got time to get your gear ready, find a good observing spot, plan your evenings.
Perfect.
And it's always worth keeping in mind those even more spectacular perihelic oppositions we mentioned, where Mars gets extra close.
Right, the really rare ones.
They occur less frequently, yeah, about every 15 to 17 years. The last truly notable one was back in 2018.
I remember that one. It was huge news.
It was. And the next really good perihelic one is anticipated around 2033. So while 2027 won't be quite that close, it will still be an absolutely incredible sight. Definitely worth observing.
Okay, fantastic.
Yeah.
So you've marked your calendar for early 2027. You know when to look. Now, what should you actually look for when you get your telescope out? I mean, we need to set realistic expectations, right? It won't look like the stunning up-close photos from Perseverance.
Oh, absolutely not.
Yeah.
Setting realistic expectations is key, but the primary targets you can see are truly rewarding. Well, the first thing you'll notice is just the ochre disk itself. Its distinct, beautiful reddish-orange color.
The red planet.
That's it. Comes from iron oxide, essentially rust, covering its surface. And seeing that color isn't just pretty. It tells us about the planet's history, its chemistry.
Planetary rust. Got it.
Then, specifically for the 2027 opposition, you'll want to look for the North Polar Cap, because the northern hemisphere of Mars will be tilted towards us then.
Okay, so we'll have a good view of the top.
Exactly. You'll see this as a brilliant white patch right at the top of the planet's disk. It's basically a mix of water ice and frozen carbon dioxide, dry ice.
Wow.
And watching it shrink and grow with the Martian seasons is one of the classic amateur astronomy pursuits. It really brings the planet to life.
So a little white cap perched atop that distinctive orange disk. That sounds, well, distinctly visible, almost like seeing Earth's poles from space, but much smaller, obviously.
It truly is. And then, with patience, and this is important, patience and steady atmospheric conditions.
Right, the steady air.
You can also spot dark surface markings. Now, these aren't just random blotches. They are vast expanses of darker volcanic rock, or maybe regions where the lighter red dust has been blown away by winds.
Okay, actual features.
Actual features. The most famous of these is Syrtis Major. It's often described as a large, dark, kind of triangular-shaped area.
The Syrtis Major sounds very grand.
It is. And seeing Syrtis Major through your own telescope is, well, it's really a classic achievement for an amateur astronomer. It's a real aha moment that connects you to generations of observers who've sketched that same feature.
That sounds like a really rewarding challenge. And it's amazing to think we can see these kinds of features from millions of miles away. So to get the most out of a Mars opposition, it's clearly not just about looking on one specific night. What are some pro tips to maximize the experience?
Yeah, absolutely. To truly optimize your viewing, my first tip is start observing early. Don't just wait for the official opposition date. Begin looking at Mars in the weeks, even months, leading up to it. You'll actually be able to track its apparent size growing night after night in the eyepiece.
Whoa, that's cool.
It's an amazing experience in itself. It really builds anticipation for the main event.
like watching a celestial crescendo. Nice. What else?
Another crucial tip, use color filters. This sounds technical, but it's actually pretty simple.
Okay.
A basic red or orange eyepiece filter, astronomers often use numbers, like a hashtag 23A or hashtag 21 filter, can dramatically increase the contrast between the light ochre areas and the darker surface markings.
How does that work?
Well, these filters basically work by blocking out some of the scattered blue light from our own atmosphere, and they enhance the details on the reddish Martian surface itself. It makes features like Syrtis Major much easier to discern, really helps them pop, brings out subtleties you might otherwise miss.
Interesting. So a little piece of colored glass can make a huge difference in cutting through the atmospheric haze and really emphasizing those details. What else should observers prepare for?
This one's maybe the most important. Patience at the eyepiece. Seriously.
Yeah.
Don't just glance and give up if it looks blurry.
Right.
Our Earth's atmosphere is this constantly swirling, turbulent blanket, right?
Right.
But there will be these fleeting moments, maybe just fractions of a second, of perfect stillness.
We call that good seeing in astronomy.
Exactly, good seeing. And in those moments, the image suddenly becomes crystal clear like a photograph. I remember one night, I swear I spent 10 minutes just staring, waiting for that perfect seeing moment. My eyes were watering.
Mm-hmm. Been there.
But then suddenly, bam, Syrtis Major just popped into view, sharp as anything. It's truly worth the wait. You have to be looking when those moments happen to catch those elusive details.
That makes total sense. Our own atmosphere is often the biggest hurdle to clear vision from the ground. Any final pro tips for those trying to train their eye and, really connect with what they're seeing?
Definitely. And this echoes what we've said in previous deep dives. Try sketching what you see.
The observing log approach.
Yeah. It sounds old-fashioned, but sketching forces your brain to slow down and register subtle details you would otherwise completely miss if you were just glancing. It's the absolute best way to train your eye and enhance your observation skills, whether you're drawing Mars, Jupiter, the moon, whatever. It turns passive looking into active seeing.
Excellent advice. Okay, so we've covered the what, when, and how of observing Mars during opposition. But to truly appreciate what you're seeing through that eyepiece, let's maybe zoom out a bit. It's not just a red dot. It's this dynamic, incredible world. So what does all this observation mean for our understanding of Mars beyond just the viewing? Here's where it gets truly fascinating, I think, exploring some of the most mind-bending facts about the red planet itself.
Oh, absolutely. Mars is truly a planet of extremes and wonders, and each of its unique features tells us something profound about planetary evolution.
Okay, hit us with some facts.
For instance, it's home to Olympus Mons. Heard of it?
The giant volcano, right?
The giant volcano, the largest in the entire solar system. It stands at approximately 21 kilometers high, that's about 13 miles, and is roughly 600 kilometers or 373 miles in diameter.
Whoa, how does that compare to Everest?
It's nearly 3 times taller than Mount Everest.
3 times?
Yeah. And this isn't just a giant mountain. It's a profound insight into Mars's past geological activity.
Mm-hmm.
Unlike Earth, Mars seems to lack active plate tectonics now, meaning its crust doesn't move around like ours does. So this allowed volcanic hotspots to just sit there and erupt in the same place for millions, maybe billions of years, building up these colossal record-breaking structures. It tells us Mars once had, and perhaps still has deep down, a very different internal dynamic compared to Earth.
Wow. 3 times taller than Everest. If you were standing on Mars, like at the base, would you even be able to see the summit? Or would it just be this impossibly distant rise because of the planet's curve?
That's a great question. Because of its immense width and the actual curvature of Mars, you'd likely never see the summit from the base. You would always be way beyond the horizon. It's just that vast. It's a testament to its sheer scale.
Incredible. What else?
And then there are its unique blue sunsets.
Blue? On the red planet?
I know, right? Unlike Earth's fiery red sunsets, Mars experiences blue ones. This isn't just a quirky visual, it's physics. It's because of its very thin atmosphere and how the fine dust particles suspended in it scatter sunlight.
Okay.
Well, on Mars, the dust tends to scatter red light forward, keeping it near the sun and the sky. But blue light gets scattered more broadly across the sky, except right near the setting sun, where it penetrates the atmosphere more directly. So you get this bluish glow right around the sun as it dips below the horizon. It shows us how profoundly different atmospheric compositions can affect our perception of light.
Blue sunsets on a red planet, that's quite the contrast. And yeah, a real visual treat for future Martian explorers to look forward to.
Definitely. Another intriguing fact is the potential for rings in the future.
Rings? Like Saturn? Mars?
Potentially, yes. Mars has two small potato-shaped moons, Phobos and Deimos. Phobos, the inner one, is actually gradually spiraling inward towards Mars due to tidal forces.
It's getting closer.
It is. And scientists predict that within maybe 40 million years or so, it's expected to either crash into the planet or, perhaps more likely, get torn apart by Mars's gravity.
Torn apart.
Yeah, ripped into pieces by the tidal forces. And those pieces could form a magnificent, albeit probably temporary, ring system around Mars.
Whoa.
It's a glimpse into the dynamic, sometimes violent evolution of planetary systems.
So Mars might have its own rings someday. That's a wild thought. A truly cosmic makeover happening on a timescale we can barely comprehend.
It's an incredible possibility, isn't it? We also know Mars frequently experiences massive global dust storms.
Right, I've seen pictures of those or artist impressions. They look intense.
They are. These storms can sometimes grow to envelop the entire planet for days or even months. They're not just minor weather events. They significantly affect visibility, both from Earth and for our rovers on the surface. They block sunlight, which impacts solar power, affects temperatures, and generally makes life difficult for our robotic explorers.
So a major operational hazard.
A huge one. But they also give us critical insights into planetary climate and atmospheric dynamics on a scale we just don't experience here on Earth.
And it has some truly epic geological features too, right? Things that hint at a maybe more violent or active past.
Absolutely. Valles Marineris, this isn't just a canyon, it's a canyon system, one of the largest in the entire solar system.
How big are we talking?
It stretches over 4,000 kilometers, that's about 2,500 miles, and reaches depths of up to 8 kilometers or 5 miles in places.
Good grief. How does that compare to the Grand Canyon?
It absolutely dwarfs Earth's Grand Canyon, makes our canyon look like, well, a mere scratch on the surface. Its formation is still debated. Maybe massive tectonic shifts, maybe volcanic rifting early in Mars's history, but whatever caused it, it showcases the immense geological forces that once shaped the planet.
And its atmosphere. You mentioned it's thin, causing the blue sunsets. Not exactly welcoming for us humans, I gather, but what does it tell us scientifically?
Not welcoming at all, no. Its thin and harsh atmosphere is composed of about 96% carbon dioxide, with very, very little oxygen.
96% CO2.
Yeah. And that thinness and composition contribute to the extreme temperature fluctuations and make it impossible, currently, for liquid water to remain stable on the surface for long periods. It just boils away or freezes. It's a stark reminder of the delicate balance of conditions required for life as we know it.
A very different world.
Very different. Though on a slightly more relatable note, Martian days are just slightly longer than Earth days. A day on Mars, called a sol, is approximately 24 hours and 39 minutes long.
Oh, so 24.6 hours, basically. We'd adjust to the workday pretty quickly.
We probably would. That extra 40 minutes might be nice, actually.
Huh. Maybe. And the actual landmass, does it compare to Earth in any surprising way, size-wise?
This one surprises people.
Yeah?
Surprisingly, yes. The total surface area of Mars is roughly equivalent to the total land area of Earth.
Really? So if you took away Earth's oceans...
The remaining land would be about the same surface area as all of Mars. Of course, Mars is much smaller overall, but it doesn't have oceans covering most of it.
Huh. Interesting perspective.
But don't let that comparable land area fool you about conditions. As we mentioned, it experiences those extreme temperature fluctuations. It can reach a balmy 20 degrees Celsius, maybe 70 Fahrenheit, at the equator during the day.
Pleasant.
But plummet to minus 140 Celsius, that's like minus 220 Fahrenheit, at the poles at night.
Yikes. Talk about needing to layer up.
Seriously. It just highlights how different planetary sizes, atmospheres, and distances from the sun can lead to vastly different thermal regulation systems.
What an incredible, dynamic, and frankly, extreme place. This deep dive has truly shown that Mars opposition isn't just a neat astronomical event. It's a truly cosmic alignment that offers this unique opportunity to witness the red planet in all its glory from our own backyards. And with the insights and practical tips we've shared, you, our listener, are now hopefully armed with the knowledge to make the most of it.
That's the goal.
We're definitely incredibly excited for the upcoming 2027 opposition window, whether the exact date falls in January or February. It truly is your golden opportunity to see the red planet at its absolute best. Get ready to explore.
Yeah. And maybe if we connect this to the bigger picture, what does the dynamic, ever-changing nature of Mars, from its vast canyons and towering volcanoes to its potential future rings and strange blue sunsets and even its extreme temperatures, what does all that teach us about the evolution of planets in general? And maybe about the endless wonders still awaiting our gaze out there in the cosmos. Ponder that. maybe, as you prepare for your next observation. Know that when you look at that ochre dot, you're connecting with a planetary saga spanning billions of years.